Good morning, batch 12. Good morning, guys. Welcome to C-High Online Training. Our subject for today is all about Electric and Electronics Fundamentals 3 or EEF3. The lessons for today is LC circuits. So let's start. First, we're going to define what is LC circuit. On the board, an LC circuit is also called resonant circuit, tank circuit, or tune circuit. An LC circuit is an electric circuit, consists of an inductor represented by letter L and a capacitor represented by letter C, connected together. The circuit can act as an electric resonator, an electrical analog of a tuning port, storing energy oscillating at the circuit's resonant frequency. Now, we have two types of LC circuit. Number one is series LC circuit. And this is the diagram of a series LC circuit. So, as you can see, the upper terminal of the capacitor is connected to the source voltage, and the lower terminal of capacitor is connected to the inductor, and the lower terminal of inductor is connected to the source voltage AC. So this is series LC circuit. And we have another series LC circuit, which is, as you can say, that the capacitance here, we're going to change to capacitive reactance. And then the inductance here is we're going to change to inductive reactance. Okay? With the given value of frequency and AC voltage or source voltage. Now, let's compute the capacitive reactance, XC, and the inductive reactance. So, with a given circuit here, with the capacitance value of 220 picofarad and an inductance value of 150 microhenry, with an AC voltage of 10 volts and a frequency of 1 megahertz. So first, let's have a formula. The formula is XC is equal to 1 divided by, open parenthesis, 2 times pi times F times C. Then another formula is XL, or inductive reactance, is equal to 2 times pi times F times L. Solution. Let's solve for XC is equal to 1 divided by, open parenthesis, 2 times pi times F times C, close parenthesis. So let's substitute the value of pi, F, and C. So your XC now is equal to 1 divided by, open parenthesis, 2 times 3.14, which is the value of pi, times 1 megahertz, this one, the frequency, times 0.000000000022 farad, and which is the value of the capacitance. Okay, here you can see that the value is 220 picofarad. Do not write this value here because the answer will be wrong. So you have to change this one to farad. Okay, how? You multiply, divide this one. You divide this by 1 trillion. Okay, 1 trillion. This is 12 zeros. Okay, so 220 divided by 1 trillion, which is equal to this value here. Okay, so what is the product of this? And then divide the 1. Okay, so your XC now will be equal to 723.79 ohms. So this is the value of capacitive reactance. Next, we will solve for XL. So XL formula is equal to 2 times pi times F times L. Substitute the value of pi, F, and L. So your XL is equal to 2 times 3.14 times 1 megahertz times 0.00015 Henry. And this is the inductance. As you can see here, this is 150 microhenry. So do not write 150 here because the answer will be wrong. So we have to change this one to Henry. How? This is micro, meaning 1 million. So you have to divide this one, 150 divided by 1 million, which is equal to 0.00015. So your XL now will be equal to 942 ohms. Okay. Next, compute the total impedance. The symbol is Z. Total current. The symbol is IT. Voltage of capacitor. The symbol is BC. The voltage of inductor. The symbol is VL. And the total voltage, VT. Okay. So formula. This is the formula of Z, which is equal to the square root of open parenthesis XL minus XC squared, or Z is equal to the square root of XC open parenthesis XC minus XL squared. Okay, so if why two formula here? It's because if XL is greater than XC, so you write first the big value minus the small value. If XC is greater value, so you have to write the XC first minus the XL. Okay. Next, you're going to solve for IT. So this is the formula of IT, which is equal to source voltage divided by Z. So remember, Z is impedance and source voltage is this one, the 10 volts. Then solve for the capacitor voltage, which is equal to total current times the XC. This is total current, so you write it here, the value of total current. Next is inductor voltage, which is equal to total current times XL. Okay. Next is the solution. So solve for. So this is the value of XC and XL. So we are going to solve for the Z. Okay. So substitute the value of XL minus XC. So this is XC and this is XL. Okay. So Z is the square root of open parenthesis 942 minus 723.79 close parenthesis squared. And Z is equal to 218.21 ohms. The next, you are going to solve for the total current. So IT is equal to Vs divided by Z. Substitute the value of Vs divided by Z. So 10 is equal 10 divided by 218.21. So your IT now, total current, is equal to 0.0458 ampere. Next, solve for the capacitor voltage. So substitute the value of IT and XC. So your IT is equal to 0.0458 times 723.79. Your capacitor now is capacitor voltage is equal to 33.14 volts. The next, solve for the inductor voltage. Okay, so substitute the value of IT and XL. So your VL is equal to 0.0458 times 942. So your VL now is equal to 43.14 volts. Okay. Then we are going to check if this capacitor voltage is correct or not, and the inductor voltage is correct or not. So we are going to check by solving the total voltage. So the formula of total voltage is equal to the square root of open parenthesis VL minus VC or close parenthesis square. Substitute the value of BL and VC. So your VT now is equal to the square root of open parenthesis 43.14 minus 33.14 close parenthesis square. Your total voltage is equal to 10 volts. So all of this voltage here, the VL and the VC, are correct. Okay? And also the total current is also correct. Why? Because your total voltage here is equal to the source voltage, which is 10 volts. Okay? So this is how to compute the impedance using this formula, and how to compute the total current using this Ohm's law formula. We just only substitute this R. This is R, but we change to Z, which is the unit of this is ohms. Okay, and then this is the formula how to compute the voltage of the capacitor, and also for the inductor voltage. Okay, so that's it, guys. This is all about the series LC circuit. So thank you for watching. See you next on CHI online training. Thank you, guys.